measuring system to be used for unmanned operations in lathe. Okay, so for this presentation, I will first go through the general applications of our probes and our probes unit mechanism. And I will follow up with that on the software or macrocycles that are to be used together with our probes. And lastly, we will share some examples where we have our systems installed in the Mazak lathe. So in general, we can use our TC probing systems for the following fields of application. We can use it to determine the workpiece's position. We can also use it to set the work coordinate system with an option for predetermined set position. With our probes, we can also do a temperature compensation of an axis. We can check the parts tolerance. We can automatically do a tool wear compensation into the tool table. And we are also able to calculate the distances and angles, which allows for you to check the profiles that are turned in the lathe. Here we have a cross-section of our patented multi-directional phase gear, the 𝐁𝐞𝐭𝐭𝐞𝐫 𝐏𝐫𝐨𝐝. If you can see here in the middle, this phase gear has many gear teeth. So when it opens up, it looks like a shark. So we call it the 𝐁𝐞𝐿 360. It's patented, and it is for better precision, because with this phase gear, we can define the deflection direction, which allows for non-lobing measurement, and the torsional force is adopted by the phase gear, absorbed by the phase gear, which allows for a constant measuring force in any approach direction. And most importantly, when it comes to a rest, when it's not deflecting, the home position, the resting position of this probe is always the same. And we are also able to measure in 6 ways, which means you can measure in a upward pulling direction. Okay. So for lathe, we have a dedicated range of probes we call the T version, the tough probes. It is designed with a higher measuring force for mounting in tool turrets because there are high vibrations and also long chip entanglements which might hurt a normal probe. As you can see, our probing force or measuring force is at least twice or more than the competition. Okay. So next we go on to the software or macro cycles that are used together with our probes. So here you see an overview of a range of probes that we have. Okay, and we have a variety of macro cycles for use of our probes. And in the lathe application, we would always go with our quick start T. Okay. So with quick start T, you can see here, no laser point. Okay, we can measure a single point in X, Y, or Z. Okay, we can measure the inside diameter, can measure an outside diameter, we can measure a groove, we can do a protected move, and we can also calibrate in X, Y, and Z. Okay? So, a possible measurement task with our quick start T is a single point measurement in X, Y, or Z direction. And we can also do a 2-point measurement for inside width, outside width, grooves, and angles. Okay? So in the lathe, we can mount it axially or radially. And we can mount up to 5 stylus on the probes. Okay? With a single point measurement, we are able to use a different configuration of stylus, and we can probe with the straight stylus, we can probe it in the z-axis, or with a T-stylus, we can also probe in the z-axis. And with the T-stylus, we can also probe in the x or y-axis for a single point measurement. Okay? We are also able to measure inside diameter like this, or an outside diameter. Okay? And the results of two-point measurement, we can have the width, the center of the circle, deviation of the width, or deviation of the center, your XY position or XZ position for lathe. We are also able to measure with 2 points an inside width or thickness of outside width, as you can see in the pictures. If using one stylus is not possible, we are also able to use 2 stylus to get the inside width. Okay, as you can see on the top left picture. We are also able to index the C-axis to measure a groove or thickness. And we are also able to program for absolute or relative positioning move. And if the target is reached without deflection of the probe, the measuring block will be completed without an error message. But if the probe hits an obstacle during positioning, it will move back to the start position, switched off, and then an error message will come out on the controller. With this, we are able to adopt and adapt individual processes for your turning operations, unmanned, so we can define the tolerance and the correction limit for your tool wear. We can fully automate workpiece measurement and correction, which allows us for maximum in-process reliability and also gives you a closed process for mass production, a closed loop process. So now I will go through some solutions that we have in the Mazak lathe with Mazak Singapore. So first up, we have our TC5410-T on the QT Primos 100 SG. So as you can see in the picture, it's mounted radially in the turret. It is used for workpiece measurement on the main spindle and give an auto tool wear compensation to the controller. Next up, we have a TC76T mounted on a QTG50 SG on a grinding hole process. This component measurement is done in the original fixturing, and thus we can virtually have a perfect run out. So here's a video. Okay. It is doing an internal grinding, and after that, it uses our probe to go in and measure the diameter. So just 1 point, and the diameter will be displayed on the controller. Okay, 20.03. Another example we have with a TC54-10T, also mounted axially on the QTE 200 SG. It is highly precise despite of the viscous oil, and our touch probe is resistant against chips and vibrations. Okay. Another example we have, it's on a turn mill with our TC6330. It's a modular probe, and the TC76T. It is mounted in the Integrex I450H. It is for measurement of a workpiece for auto tool wear compensation. In this example, the effective stylus length is 200 millimeters, and the stylus ball diameter is 10 millimeters. With this, we have a repeatability of 1 micron and an accuracy of 8 microns. Another example of the TC6330 and TC76T on the Integrex E500H. It is for the measurement of the geometrical dimensions and tolerance, and also the internal profile. In this picture, you can see we have a very small 5-way stylus, 5 stylus with diameter 1 millimeter. The setup on this is using a 400 millimeter carbon fiber extension, and the star stylus has an effective length of 5 millimeter each and a ball diameter of 1 millimeter each. In this slide, we are doing a ball calibration of the 5 individual stylus. Okay. Next, we go through special probes now for tool wear and tool monitoring. Okay, this is our 𝐁𝐞𝐭𝐭𝐞𝐫 probes. It's a different touch probe from before. It is used for tool length measurement, tool wear measurement, and tool breakage detection. Here we have a smaller example. You can see under the spindle, a smaller size, our 𝐁𝐞𝐭𝐭𝐞𝐫 for turret lathe. It is for quick tool length measurement and breakage detection, and we are able to detect tool breakage of tools with diameter as small as 50 microns. Here you can see a 𝐁𝐼𝐴 mounted on a lathe. It is a quick tool length measurement and breakage detection. You can use this in process of the turning. In a typical turning center, we can just call the tool to go in and measure to see if there's any breakage or if the wear exceeds while the machine is turning with the part still in the spindle. So next, here's a video to show our 𝐁𝐼𝐴 in measurement. So here, with the turning tool coming in, touch on our 𝐁𝐼𝐴 to get the tool length, the tool setting, and then straight away it goes to the machining. Okay. With our TC76, we are also able to put in a universal lathe as a retrofit solution for rapid tool length measurement and breakage detection in X and Z direction. So we have a good solution where you can see there's a sleeve, there's a cover that covers up the square stylus to protect it from the entanglement of chips and dirts. Okay. Here is a video that will show our TC76 with the sleeve protection in action. So here we are turning, and straight away we go and measure the tool wear. Sleeves open up, the tool comes in, touch it, and it's measured. Continues machining again. Right? Now it's a readout tool. It's machining. And then now it goes on. Sleeves open and measures again the tool. So all these measurements are done unmanned and automatically. There is no need for the machine to stop. There's no need for the workpiece to be taken out for tool wear monitoring. Okay? So in summary, from Bloom Novotest, we have solutions from pre-machining all the way up to post-machining. For pre-machining, we can do a tool setting with a contact or non-contact setup. We can also do workpiece setting. During machining, we are able to do a tool load monitoring. We can also monitor your tool form, and we can also visualize your machine condition and process. After machining, we're able to do a series of different measurements on your machine workpiece in the machine in process. We can do a feature measurement with geometrical dimensional measuring reporting. We can do roughness and profile measurement. We can also do automatic bore measurement. Okay? So we hope that you will not be a square, you will adopt our solutions, and you'll be around for the next industrial revolution. And with this, my presentation is coming to an end, but with a lucky draw, I have a quiz for you guys to answer. So if you guys can give me the name of our patented 360 phase gear mechanism, you guys will win a Starbucks voucher, $50 Starbucks voucher. So please key in your answers in the chat, and our panel will decide who is the winner at the end of this event. So thank you very much. I will now hand over to Mr. Chan from Open Mind. Thank you.
Okay, thanks, George. The next speaker will be Mr. Chan from Open Mind.
Hello, everyone. It's me again. My name is 𝐁𝐞𝐭𝐭𝐞. So let me introduce myself again. I understand that just now, I think some of you could not hear my voice. I'm the Sales Technical Manager for Open Mind Asia Pacific. Open Mind itself is located in Germany. So we do all our software development back in Munich. Other than this, the CAT teams are located in Italy. Myself, I'm located in Singapore here, which is the Asia Pacific regional office for the Open Mind pre-sales and after-sales support. So just now, George have shared with us about the drone product. So basically, these are three main functions of the touch probe. I will go to one of the, so this is the two settings. I will not highlight very much on this. So our main focus is how do you create the probing cycle by a CAM software. I think most of us with your CNC machine, it may come with the probing system itself. And how do we actually use it to use the full potential of the probing system? I think generally, at times, I can see many of us is that we use it for manual settings. So what are those? So while we go into individual cycle, we have heard a lot about the advantage of using touch probe. I think my main focus here is not to say what are the advantages, but rather how to make it successful. How are we going to use our probe well? I mentioned about setting for datum. Many of us will probably use with an MDI, manually move your touch probe, touch the parts in the X directions, Z directions, and then register that execution. So are we going to do the same thing for all other measurements? Is this a very secure method? As we have understand just now from George's presentation, there will be some kind of a lucky draw. So I want you to pay attention to my presentation also, so that I will be asking some questions that if you answer it right, you may have the chance to win a prize. These are a few generally used probing cycle. Let's elaborate a little bit more on each of the applications. In this slide here, on the left picture, this is the user interface of a general rectangular probing. So as compared to manual data input, you have to remember what are the macro cycle name, the parameter. But back at here is just like the way you use CAM to program your 2D pocketing, drilling cycle, simultaneous movement directly on the 3D CAD model. So with kind of a feedback, you can select the geometry, and then you define your probing is inside or outside. So there are a lot of CAD feedback right in front of you. Due to time constraint, I will not be playing a lot of video. I will skip. This is another example of another probing cycle. It is about circular. It can be a borehole or can be a shaft. There are a few methods to measure these circular parts using 4-point or 3-point. I think what is more important is you can see that you do not need to measure a full circle. From a CAD/CAM system, I can actually locate what are the points, even the angle may not be symmetric. More important thing is that by doing this through a CAM software is that you can do verification to make sure that the touch probe will not collide. Take a look on this picture over here. This is a shaft. If the infit distance of your touch probe is too wide, you may hit onto the opposite side wall of this pocket. So that may result some breakage or whichever. So to avoid all this, just like you may break your cutter, you can simulate the whole probing process. In George's presentation, he mentioned about measurement. The touch probe can also help you to adjust your cutter geometry. So what are kind of conditions that the probing cycle are so smart that they know how to adjust? I think in terms of measurements, whether the part is milled to size or undersized, we need an additional parameter. What is this additional parameter? Yes, you are right, tolerance. Without tolerance, we cannot come to any conclusion whether the parts is milled to size or undersized. There are various ways for you to input this tolerance. Automatic way, if you have a borehole or shaft, based on the diameter, define your ISO fit H6 or H7. Automatically, we will create the tolerance value. Or you have upper limits, lower limits, or symmetrics. So there are many ways for you to define your tolerance. This is one of the important factors. Other probing cycle is that based on point, you can see from George's previous presentation, talked a lot about single point. So we can measure single point in Z-axis direction, X or Y-axis directions. I think expand panel. Back to setting of a workpiece coordinate system. Any of the measuring cycle can allow you to set your datum as a rectangular block or a cylindrical bar, or even in a single axis direction. When you do the program, you could be using work coordinate system G54. But when you measure the parts and then to set it as your parts datum, you can assign with a different work coordinate system. So with all this, the post-processor will output it correctly. These are not through manual work or whichever. So this work coordinate system, you can be done parallel to your first milling operation. For example, your first milling operation was facing. So let's set the parts datum first. I think this picture will help me to explain further. What if your parts are not clamped in a three-axis manner where it's parallel? It's sitting at kind of an inclined plane. How do you do the datum setting? So with the touch probe and your CAM system, you can automatically know what is the two inclinations. You do not need to carry a calculator beside you on your controller and try to figure out what is the actual angle. Just like you do 3+2 operations, the probing can be done easily in that manner too. You may have some casting parts. In some cases, if your casting that you receive have different kind of thickness, it's not consistent. And your number of parts that you need to machine are not a lot. So to save your featuring work, you don't have to spend a lot of time to fabricate the feature. Design a very bulletproof kind of feature. Use a simple general clamping system that you can secure the parts well. By using a touch probe, you start with the critical phase and use that as a reference. And from that, you use that as a reference point to create your new work coordinate system. The probing takes just 1 or 2 minutes, but it saves you a lot of time than to make a very sophisticated jig or feature. We have mentioned about adjusting cutter geometry. So how does this work? Here, you can decide your probing to follow by after milling operations, or put right behind after all your parts have been machined, whether it's holes or a milling contour. The criteria is that within the hypermill job user interface, we will always reference to one of your milling operations. For example, this milling operations, you have a very critical tolerance that you need to meet. So with this reference, we were able to adjust the cutter diameter or the tool length based on the tolerance that you have input. Let's say after machining, after the probing measurement, the part is bigger by 20 microns, maybe due to tool wear. You have the various ways to control it, to say that, hey, adjust this cutter automatically according to the additional allowance, or give me an error message, let my operator decide, or straight away jump to error message, the whole machining stop. Depends on your machining requirements. Sometimes there's no point to continue to readjust the cutter because the tool is already wear. So it's a good thing that we have kind of decisions by the machine operator to see that, hey, yes, this is the very tough material. The tool life have come to its limit. Additional kind of measurement over the angle. This is the user interface of how this cycle will work. As you can see, you just have to define a straight line, and automatically we can determine what is the best 2 point for you to probe. Next, we talk about 3D point probing. What I explained just now are purely 2D. In this picture here, you can see that the shape are of an irregular shape. It's not a planar face, it's a freeform shape. And the criteria for this is that you need a surface. So my statement here says that the approach will be in a normal to the surface. That means when the touch probes touch the stylus start to move in, it will move in XYZ direction. why do you need such a sophisticated kind of a movement? I try to explain to you now. In this picture, on the left side, let's say that this is your target point. Based on one axis direction, in this case in Z direction, as the probe moves down, before it can hit into this green point here, the spiral is already touching onto the side wall. So you're never able to get a good result. So this is absolutely not possible. So the correct approach is you have to do it in vector direction, X, Y, Z movement at the same time. Wow, I've mentioned so much about how 𝐻𝐵𝐴 can generate the probing cycle. I think what is important is how do you translate that into NC codes that the master throw can read it, interpret it, run it successfully without any error. As you can see over here, when I talk about probing, I'm not just talking about just 2D probing. It can be on any of the multi-axis, let it be 4-axis or 5-axis machines. In this case, you can see that the parts that we are probe is rotated with a certain angle. These are the exact cycle of the Brom. With the CAD-CAM, we don't have to try to remember all the G codes, each individual parameter. Let 𝐻𝐵𝐴 take care about what are the relevant important parameters to run this job safely. Let me play a video. This was created by my colleague Elliot Chua. As you can see, like all your machining job, whether it's turning, milling, or turning, probing can be added inside your whole machining process. We start to create a probing cycle right now. There are various ways of probing cycle inside 𝐻𝐵𝐴. Let's choose one that is relevant for this part. In this case, it is a rectangular shape probing. Like milling cutter, instead of selecting milling cutter, I now select a touch probe. Next, I define the geometry of this rectangular that I intend to. Again, from the CAD model, I extract the geometry directly. With the feedback, you know that if the probe safety height is in the right position, remember, this is in a 5-axis part, so it's not a 3-axis part. All collision check have to be taken care of. Let's input the geometric tolerance. After this has been done, we have to decide what strategy do we want. This is purely for measure, or you have to reference to a machining job, or to set datum. In this case, it's just for measurement purpose. The probing two paths have been created. I continue again. Now we can do the simulations. After simulations, the NC file will be created. So this is the real action on the machines. This we captured on the Mazat HCR 5000. This is the horizontal machining center. So without any further NC editing, what you generate on the CAM we can transfer directly to the machines. So there's some, I think this come to the end. Let's continue with my next slide. We have talked so much about probing. I think beyond measuring of this cycle, what else can you use on your touch probe? I think the key thing is applications. While we look at applications, let's look at what are the challenges that we encounter, whether your whole machine process is fully automated or semi-operations. Here, the common thing is that the parts was loaded or crammed incorrectly. The raw material that you used was bigger or smaller than it intended to, or the parts was not crammed flat or parallel. So this picture here shows that after few hours of cutting on a very hard to machine material, you realize that the material is not sufficient enough to have a complete. So these are things that we can prevent by using our standard probe that is available on your machines. So very quickly, I will just jump into how can you make use of such applications. So the first one is, like for example, I can quickly measure the part. Is it sitting in the right orientation that I intended to? Second, what about the flatness? You can also check not just on the physical parts. In this case here, the blade here, I can also check on my clamping device, where this clamping device is mounted together with the parts. There are many ways, as long as you know the application, we can make full use of that. This is quite a heavy topic about best fit. I will just go very quickly before I show you one other example of using best fit. In this picture here, you can see that these are parts that it designed by a feature to cram it. In many cases, we assume that with a feature, our parts will be secured in a very constant, stable positions. However, there are always some challenges that after different force of cramping, the parts may be sitting slightly different from each operations. So how do you overcome this? I think it is very ridiculous to say that, let me check what is the part that is out, and then use the cam to rotate the position, reprogram it. Are you going to do this for every part? The faster way and more efficient way is that you can use your best fit operation, measure the parts. After that, the best fit can automatically compute what are the angles that it need to be compensated. Another example about using best fit is, look at this picture. This is a huge part. It is impossible for us to crop the alignment of whichever. I think the faster ways and easiest way is that after clamping, just check what is the orientation and then use best fits to automatically align your NC program to suit to this part. Another example is 3D printing. I think there are things that we know about what 3D printing cannot be fulfilled. One of the key things is that this building element, if you need to remove it, especially on the metal material, it is very difficult. And how do you locate it back to your CNC machines that your alignment is correct to your CAM programming? I think the best fit will be the ideal case to support it. last, remember about adaptive manufacturing. This is a very heavy topic as well. Again, with your existing touch probe, you can extend your manufacturing process in a very wide way. So adaptive machining, in this case, I try to explain it short, is that you have an original 3D CAD model, but your actual parts geometry is not formed exactly to your 3D CAD model. It could be from a casting, or it could be your after machining due to some kind of deformation or whichever. You're never able to mill to the shape of your original CAD model. So what we can do is that first, using your CAD model, you can create some prodding positions. Next, measure the parts again on your parts that have been deformed. With that, you were able to know that what are the deformations, and then let the software compute it. How should the shape be formed? So this is another example that what I was trying to say is you have the target point and the new measure point. And using the CAD, in this case, using our HyperCAD S, we can create the deformations. I will skip this video. So I come to an end of my presentation. I thanks for your attention. So, ladies and gentlemen, I have a question for you guys. So please, if you answer it correctly, you will get a chance to win surprise. Please name one of the probing cycles that Hypermill can support. I think it's a very easy question. Good luck to you. Thank you.
Mr. Chan. Last week, we had Mr. Soriano from Mozart, who will be sharing with us more on how automation can assist operations.
Good afternoon, ladies and gentlemen. I'm Soriano from 𝐻𝐞𝐭𝐭𝐞𝐫 Singapore. I've start working in 𝐻𝐞𝐭𝐭𝐞𝐫 since year 2000 as a design engineer. And just recently, I started to be part of the product sales. And I'm happy to be part of this and have this opportunity to introduce to you our Mazak machines and automation solutions. And I hope I'll be able to provide you some valuable updates on our machines and also the latest automation systems that will make possible unmanned operations. Unmanned operation had been existent since the early 1980s in Yamazaki Mazak factories, as you can see in our slide on the top. We have our flexible manufacturing system, we call FMS, and it has advanced now to what we call iSmart Factory, which made Mazak to continue to excel in producing premium and high accuracy and high performance machines. Together with our high standards in our parts inspection and using latest measuring devices, rest assured that our machine components are of the highest quality. Furthermore, with our high-skilled assembly engineers, with the proven and up-to-date assembly processes and procedures using latest laser calibrations and equipments, rest assured that our CNC machines, what we produce, are of the highest accuracy quality standards. Singapore has been selling machines worldwide for more than 30 countries, including Japan, Europe, USA, and of course, Asia, Southeast Asia. Singapore-made machines are made as what we are showing in our factory on the top. We are also using green energy to produce our machines. Okay. So I'd like now to ask you, which art industry are you in? And maybe what kind of components are you making? You may be part of the automotive industry or maybe part of the semiconductor. And of course, our main concern is how can we be more productive in producing these parts? Well, the answer might be automation. Because automation will make the production of parts more productive. And with this, Mazak might be able to provide you machines and automation solutions. I would like to introduce to you our latest model. We call them Mazak QTE series, equipped with the Mazatrol Smooth Easy controller. It is of two variants, which is the 2-axis and turn mill machines. So it is equipped with the latest NC controller. We call it Smooth Easy. QTE, the meaning of QT is basically coming from the Mazak Quick Turn series family. And E literally means easy. EASY. Easy in usage, easy in operation, easy in programming, and easy to maintain. So this machine was produced to be affordable, reliable, and with the highest precision and accuracy. So with these machines combined with our automation experience, we might be able to provide you solutions of unmanned operation to fulfill your productivity. Now I would like to start about talking more about unmanned operation, which I categorize into two categories. First category would be the low mix and high volume production automation. Second category would be the high mix, low volume production. Okay. This is one of probably the most popular example of a low mix, high volume production automation, which is a machine equipped with a single gantry loader. Okay. So this type of automation is up to now is the most reliable way to transfer and load materials to your NC machines. And surely this can work 24 hours non-stop. Okay. So this is one of the possible ways wherein unmanned operation high productivity can be attained. Would like to share to you some of our machines equipped with gantry loaders. The first one on the left is machine is QTG50SG equipped with a compact loader. As you can see, it's a very compact automation system. If you are having floor space issues, And if your components are small, I think this would be the best solution for you to do mass production. Another example that we have done is a gantry loader equipped on a QT150 machine, and the gantry is called GL03. It's basically a 8-inch machine equipped with the 20 pallet conveyor system wherein many materials can be loaded. Maximum around 150 can be loaded on the work conveyor. So with this type of automation, you can also deal with bigger diameter work pieces. At the lower side, at the lower right, we have the QTT50 with GL01. As you can see in the middle, there's and in between is a input and output conveyor. It's more of an output conveyor. So just in case you would like to receive the parts immediately, there's always a way to remove them out of the system, and while your system continuously run and continuously produce workpiece. On the left side of this slide, as you can see, Mazak Singapore have improved a lot in our experiences and know-how in designing gantry loaders. We design gantry loaders part by part. Almost all of its actuators, all of the moving parts are designed and calculated by us. We also do this rigidity and temperature checking to make sure that the system we design is able to carry on for long periods of operation. So rest assured that our automation system are very reliable and will be able to produce and meet your demands. Okay. The next slide is a gantry system. It can also be lined up in a series of lines. It can be 2 lines. It can be multiple lines, as you can see. Okay. Joining these machines with gantry will enable you to produce your components, cutting 2 or more operations in one line. This means that your raw materials from the start will end up a finished material at the end. This type of solution are recently preferred by many customers because it's space saving and immediately parts can be readily be finished. These are just some examples, as you can see on the right, of our GL combined together. Okay? And in between, there might be different types of automation which are involved, which will make it possible to continue the cutting operation. Later, I will show you some of these examples. Okay? On the left is a 3-machine with gantry loader. So this is actually, we have done this in one of our customers. As you can see, it was drawn in very detail. And the customer was indeed very satisfied on this automation system. So this automation system was done for this Brazilian customer who is producing a piston for after sales for tractors. So as you can see, it starts from the very first loading conveyor, then the GL. It has 3 GL because it has 3 machines. We load the workpiece one by one, and as it finishes its cutting, it will go then to the interval automated system. In this area, there will be orientation devices, there will be turnover devices, and many sensing automation system that will ensure that it will make sure that the next operation is safe. Okay. As you can see, the workpiece was now taken out to the second machine, and this second machine requires orientation. So if we're not able to orient the work properly, there will be a disruption on the system. But with all this know-how and all these automations involved in between machines, we are able to continue the automation from start to finish. This is the in between the second machine and the third machine, wherein it transferred the workpiece from the second machine to the third machine. Okay. Then finally, after the third machine has cut, final workpiece is produced. So as you can see, gantry systems are also reliable, very reliable for mass production. It can be put in a series of lines. It can be also done in parallel lines wherein more operations are required. So if you have any inquiries or you would like to inquire whether your parts are possible to be automated using our machines and our GL, please do so. Approach our sales and they will be able to provide you quotation and also give you some solutions on how to do your workpieces. Okay. Again, these are some examples of our gantry loading system. First one is a outer bearing. This workpiece will be for very thin work. Very thin work also requires special solution. Of course, I cannot share, but we have this solution even up to a thickness of around 3 to 4 mm thickness plates. We are able to pick the workpiece one by one, even though it is stacked in a vertical position. Okay, so with this know-how, even your workpiece is very thin, we are able to mass produce. Next example would be the turnover station here, which we have equipped on one Indian customer. His workpiece is automotive. So the main solution here is to do 2 operations with one gantry loader. Okay. So after the first operation, the workpiece will be unloaded, and of course the next piece will be loaded. The first piece unloaded will then be turned over, ready to be picked up and be loaded again for the second operation. In this way, we will be able to save time also. And we will be producing the workpiece with 2 operations. Okay. The next sample we have is this orientation device. Also, we have done for Indian customer whose parts are gears. Okay. Sometimes gears require special clamping systems, wherein it has to be clamped on the gear root. So in this case, orientation device is a necessity because without orienting the workpiece properly, the chuck won't be able to clamp correctly, and it will create an error in the system. But with this orientation device, it will accurately orient the workpiece, so there will be no issue. On the top right is an example wherein we provided a shaft work solution loader for our customer. You can see on the loading system, it loads this shaft work piece by piece. Okay, but the way the workpiece are being put on the conveyor is the workpiece are just being dumped. There's no need for orientation whatsoever. So workpiece can be loaded one time. If workpiece is getting low, the number is getting low, the workpiece can just here. You can see here, the very small protrusion is where they will put the workpiece components. Okay, so it's a very ingenious design. You can load different diameters from small diameter to big diameter. We are able to adjust the conveyor system. So for this one, it is done for a semiconductor industry in Japan, wherein they also involve using automatic path catcher, because from a long shaft, they will cut this to small pieces, to very small pieces, and then while cutting it to very small pieces, the path catcher is already collecting the small piece parts. Another one here in the middle is just a fixture, wherein most of the time workpiece are not very even in shape or not rounded shape. Sometimes are all in different shapes. Okay, so by using fixtures on the work conveyors, we will be able to load these workpieces and be able to be picked up and transferred by GL systems. Okay, right. Again, some examples to show. This one is a piston two-wheeler from Thailand, which we have provided him a solution. This customer already bought 3 units of this system because he was very satisfied on this automation system. As you can see, this is the piston. It is loaded horizontally because we have to load it using a two-hand jaws. So we have to orient the workpiece in this way. Okay? But orienting the workpiece in this way, we have to orient and make sure that the workpiece is on the proper orientation, or else it cannot be clamped. Okay, it cannot be clamped by the chuck. Okay, so again, there are many detail, automation, signals, confirmation, and checking needed to be done on gantry loaders. So gantry loaders by itself, as a standalone, may not be able to meet your, be able to do your components. You may still need some other solutions as well. This one is added up. This is another conveyor, which is also an input conveyor. For customer also wants not only to input here, but during night time, when night time, they would like to use this because there's no people loading. But during daytime or break, they want the workers to load their workpieces on this conveyor. Okay, so this type of solutions or requests from customers, we are also able to produce a solution. Okay, that's for low mix, high volume. I will now go to high mix, low volume production. Okay. Since the early years, Mazak has been doing these automation systems. One of them, the FMS. Okay. We also have these other solutions here. And what I will be discussing with you because of time constraint would be the robot, standalone robot with the machine. Okay. So I will be showing you some samples or new automation, standalone robot automations that Mazak has developed and will be ready to offer you if if you think this automation is the right solution for your unmanned operation. Okay. The first one I am showing is the TA automation system. TA means turn assist. It can be equipped with our smooth NC, any machine with smooth NC. Okay. It was developed to improve productivity by eliminating the teaching of work location and work stopper. Okay. At the same time, it has the ability to stack work pieces on top of one another to have more raw materials ready for cutting. It uses area scanning device. As you can see, the fence area is only up to here, because up to here, this would be the scanner, and this scanner is sensing the area and making sure that there is no operator close by. Because this is an industrial robot, industrial robot moves faster, okay, and loads workpiece faster. So if operators suddenly move in, so it would be dangerous while the robot is moving. But because of this area laser scanner, it will be able to detect humans vicinity is close by, then the speed will automatically decrease, ensuring the safety of people passing by. So this is one of the example of an industrial robot equipped on a turning center. Okay. Another example that I would like to introduce to you, which probably one of our recent developed automated system in Japan. We call this one easy loader. Instead of an industrial robot, this time it is equipped with a cobot. Cobot meaning collaborative robots. Okay. The main point or highlight of this automation system is that, as you can see, it was the work pieces are placed on a normal industrial pallet, okay, wherein you can put your work pieces there simply on that work pallet, and it can be transferred using forklift or manual transferring forklift. See, as you can see here. So the design is very simple. It is equipped with a 2D vision device, so it's able to locate the workpiece. So there's really no need to arrange properly or accurately the workpiece one by one. Okay. At the same time, this robot is actually very light. There's no need to mount it directly on the floor or dry pitting it on the floor because of the cobot. Okay, but cobots might be slow because of safety concerns. It had the movement have to be slowed down. Okay, but this would be very good for high mix and low volume applications, because with cobots, the operator can stand close by and can work to it side by side as well. Okay, so easily transferable, then easily set up. So this also is maybe one of your solutions when you're talking about low mix, high volume automation system. Okay. Another one which I want to introduce to you is, this time it's will be designed by Singapore. Okay. We are also using the pallets. Okay, same as the easy loader. But the main difference now is we are using industrial robot because we feel that cycles time still plays a very important role for mass production. Okay, so with an industrial robot, minimal safety fences, laser scanners equipped here, it will still be able to provide safety for operators, okay, like the TA. No? Then also this will be of easy setup, easy operation, and it will be equipped with a vision camera as well, so that it will be able to detect the work pieces. No need to arrange them so accurately. And also, we are going to provide value-added IoT software as part of the package. Okay, so with this software, it will be able to monitor your work pieces, your inputs, your outputs. It will be able to display robot status, okay, your resources, and making it ready for your industry 4.0. So with this, I think it's a good solution as well for high mix, low volume. At the same time, manage wise, okay, it's very will be give you an advantage. Okay, so this industrial robot package we will have a debut in our Singapore Discovery Technology event. Okay, this time we are also introducing an autonomous mobile robot. Okay, as you can see in the video, wherein this robot will be the one carrying the workpiece. So we are trying to show here a totally 100% unmanned operation work being carried by an autonomous mobile robot. And this mobile robot will load the workpiece. And after completion, it can also be collected by the autonomous mobile robot. Okay, and we will show also our IRP package, intelligent robot package here. Okay, and with the industry 4.0 ready software. Okay. So I'm inviting you, if you have chance to come on our Mazak Singapore Discovery 2021. We will showcase a lot of automation, a lot of ideas on how to provide unmanned production. We will feature robots. We will feature gantry loading system. You will see also the first gantry loader for our new model QTE series. Okay, then and many other more that we hope will be an answer in answering your productivity issues. Okay, so be on the lookout for this event. And for this, I want to thank you for listening, and I hope I have answered some automation solutions that might answer your productivity problems. Thank you. And my lucky draw question to you: what is the NC of our newly produced model? So I think that is very easy, okay, to answer. Thank you.
Right, thank you, Mr. Serrano. Right, let me introduce myself. I'm 𝐁𝐞𝐭𝐭𝐞𝐫, the AED, Assistant Executive Director for SPETA. Right. Thank you very much for attending this afternoon session of the outreach. SPETA stands for Singapore Precision Engineering. SPETA stands for Singapore Precision Engineering and Technology Association. So today, we have our partners, listen carefully, that sponsor the lucky draw, that is Bloom Production Methodology Private Limited, OpenMind, and Mazda. So before I announce the Starbucks voucher to be given away, let me ask the question for the lucky draw. Well, the question is, what are the 3 partners in today's event? All right. I hope you can answer correctly. Don't type wrongly. All right. So now let me announce the winner for the Starbucks vouchers that each presenter has given to you. I'll read out the name. First winner from the Bloom Q&A is, hang on a minute, I'm looking at the board. 𝐁𝐞𝐭𝐭𝐞𝐫 from Onwa, Singapore. Second winner is from question by OpenMind. The winner is Muhammad Fitri Azumi from SAM Aerospace from Malaysia. The third question, the lucky winner from is from Philippines, is Rainer B. Torres from SMC Philippines. Congratulations for all winner. Well, give me a few minutes while we are trying to hunt for the winner for the lucky draw. I think we have all the fast and furious answers are coming in, but we need to be very stringent to make sure that all the spellings are correct, because the lucky draw for the final question is actually an Apple Watch. So if you have not typed in the answer, please do so now. Oh my God, I just give you all the answer, you all type hypermind. Please, no. Well, all are coming fast and furious. But I got to check, sorry, give me a minute, I got to check, make sure that the spelling, everything is correct. Okay, are y'all ready? The winner is out. The final winner for the lucky draw is Jabu Ru from Amex Precision, and I think it's from Singapore. I'm not sure. The organizer will get back to you. So it's Jabu Ru, Amex Precision, Singapore. All right. So thank you for attending this outreach. I hope you all have learned a lot from the information that has presented to you. So I hope we can provide more of this outreach to you, and I hope you all have an enjoyable time. I hope you all like the presentation, and congratulations again. We'll be in touch with all the winners, and we'll send the vouchers and the watch to you.
Any Q&A question, answer any question.
Okay, then we shall end here. Thank you very much for your time. I hope you enjoy it. Sign off from here. I'm Samuel Kwek from SPETA. Bye.